everyone, welcome to VJ Chemistry. And today we are going to discuss about atomic structure. Okay, this lesson very important NEET exam point of view. Okay, in this lesson we are going to discuss 5 important topics. 5 important topics. Okay, important topics. Very important in exam point of view. Number one. First we have to understand some important terminologies, terms. Okay, that is what is isotope, what is isobar, what is isoelectronic, okay, what is isotone, this like, okay. And second one is very important, the Bohr atomic model. So Bohr's atomic model, okay. And third one, hydrogen spectra, hydrogen spectrum. And fourth one, quantum numbers, and quantum number. And fifth one, electronic configurations. Electronic configuration. In this electronic configuration, okay, some important rules will come. What is the important rule? Hund's rule, Pauli's principle, okay, that rule will come. Okay, this important, the 5 topic is very exam point of view. Okay, now I start with the terminology. Please know now terminology very important. What is important terminology? Terms. Now, whenever the people say iso, okay, iso, what is iso mean? Iso means same. Okay, now first one is very important. What is isotope? What is isotope? Okay, please note. Okay, before enter this topic, I will give some important basic fundamental. Whenever x is element, okay, any element, it can be carbon, hydrogen, any element. And what is z and a? Okay, now z that equal to, what is z? Z is atomic number. Z is atomic number. And what is a? A is mass number. Okay, this you have to understand basic things. Okay, the x is element. Okay? For example, I take carbon atom. Okay, carbon is a 6 and 12. The atomic number is 6 and mass number is 12. I take oxygen and 8 and 16. The atomic number Z is 6 and mass number is 16. Okay, now what is isotope? Please note, same atomic number. Okay, same atomic. I represent Z. Okay, same Z value, same Z, but different mass number, but different m, difference or different a. What is a mass number? For example, I take hydrogen atom. For hydrogen, there are 3 isotopes, right? What are 3 isotopes? One is proton, 1H1, and deuterium, 1D2, and tritium, okay, 1T3. In these 3 molecules, look the atomic number. What is atomic number of hydrogen? Is 1. Deuterium also 1. Okay, tritium also. What is the difference? The same atomic number. Whenever atomic number same element, okay, same atomic number, but different on 1, year 2, year 3, right? These are isotope. What is isotope? Same atomic number, but different mass number, okay? And number 2, please note, isobar. Okay? What is isobar? Please note, same A value. I mean same mass number. That is A, okay? Same mass number, but different atom, okay? Different atom. Listen, in different atom, what is different atom? Number of protons different, right? And number of neutron also different. Understand? Okay. Now, for example, I take argon. Okay, this is 18 and 40. Okay, I take calcium. Okay, this is 20 and 40. In these 2 elements, okay, they are complete. Argon is different element, calcium different element, right? Both are different element. It means how both are different? Different atomic number, 18 and 20. Different element, but same mass number. They call isobar. What is isobar? The species having the same mass number are called what? Collectively are called what? Isobar. Okay. Now third important, that is called isotone. This one. Third one, isotone. We also called as isoneutronic species. Now you understand, right? Isoneutronic species. Very important. Okay. Isoneutronic species. So what is isoneutronic? Same number of neutron, right? What is iso means same? What is iso? Same. Neutron, what is isotone? The same number of neutron. Same number of neutron. For example, okay, I take 1H 3. This is tritium, right? And take helium. Helium. Now, students, please understand this X is element. X is element. This is A, Z, this is A, right? What is Z? Atomic number. What is Z? Atomic number. Atomic. That equal to what? That equal to number of proton. Number of proton. Okay. What is A? A is mass number. That is nucleon. Okay. What is A? It's a nucleon. What is nucleon? The proton plus neutron. Right? So what is neutron count? The neutron is equal to A minus Z. Is a formula to find out the neutron count. Right? Now, what is neutron of tritium? What is mass number 3? And atomic number 1. What is answer? Is 2. The 2 neutron. Yes or no? In this case of tritium. In case of helium, what is mass number? 4. What is atomic number 2? What is neutron count? 2. And these two molecules have different atomic number and different mass number, but same number of neutron are called isotone. Okay, this is very, very, very important. Now, fourth important one, please note, that is isoelectronic species. This is very, very exam EPOV, exam point of view. Okay, this is isoelectronic species. Isoelectronic species. Now, what is isoelectronic? You know what is iso means same number of electrons. What is isoelectronic? Same number of electrons. The same number of electron are called isoelectronic. For example, okay, magnesium atomic number 12 and magnesium 2 plus is 10 electron. Yes or no? Okay, fluorine atomic number 9 minus photon 10 electron. Okay, whenever the plus sign represent is loss of electron, the minus sign represent adding of electron, right? Have Mg2 plus and Mg2 plus. I will give the list of the isoelectron C. Okay, and Mg2 plus and 12 2 portion 10. F 9 minus 1 10. Okay, then nitrogen is 7 and 3 minus is 10. Understand? Okay, and one more example, sodium is 11, Na plus is a 10. All the 4 species, how many electrons? They are 10 electrons. Therefore, the 4 species are called isoelectronic. The species having the same number of electrons are called isoelectronic species. And fifth one is very important. What is isostar? Please note. Isostar. What is isostar? Okay, please note. Same number count. Please, very important. Same number of electron. Same number of electron and same atomicity and same atomicity and same atomicity. What is atomicity? The number of atom in the molecule. Please note. What is atomicity? Note. Whenever I give note is very important. Okay, note. What is atomicity? Atomicity, that equal to a number of atom. Number of atom. For example, okay, I take CH4 methane. How many atom? 4 hydrogen and 1 carbon. Therefore, atomicity is 5. Understand? I take ozone O3. How many oxygen? 3. Therefore, atomicity is 3. Cl2. How many? Cl2 Cl. Therefore, atomicity 2. Okay. What is our atomicity? The number of atom in the molecule are called what? Atomicity. Okay. The what is isostar? Na? Same electron and same atomicity. For example, I take N2. Okay. I take CO. Okay. Now, in case of nitrogen is 7 electrons. 7 plus 7. Electron count is 14. Okay. Carbon 6, oxygen 8, 6 plus A also 14. Okay. They are same electron count. We call isoelectronic. Now they are containing same number of atomicity, right? Therefore, in this, how many atom? The atomicity, okay, ATO is equal to 2. In this also 1 carbon, 1 oxygen, this 2. And these 2 molecule having the same number of electron and same atomicity are called what? Isostar. This is what? The 5 important terminology in the atomic structure. Okay. Now I'm going to enter the Bohr atomic model. This very, 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 very important in our exam point of view. Please note the Bohr atomic model. Okay. This is very, very important in our NEET exam point of view. Okay. NEET and JEE exam point of view. Please note Bohr's atomic model. Bohr atomic model. This is very important. Okay. Now you know very well in the atom. Okay, in the atom is considered spherical. This is nucleus. Okay, it's the shell number was first shell and second. Okay, and 2. This is value. Okay, now see in this shell. Okay, this is n value is 1. This is n value is equal to 2 and n value is equal to 3. So what is our target? Okay, what is the Bohr target? The Bohr going to find out what? Find out the some important values. What is this? Is nucleus, right? This is a outermost shell. Now this is a radius. What is radius? You know, right? Nucleus and outermost shell. Okay. Using the Bohr model, I'm going to find out what the radius of nucleus. I will find out. Similarly, okay, this one electron and this one electron. This E1, this E2, now E3. Okay. Now 3 electron. Okay. This E1 is near to nucleus and E3 is away from nucleus. Right. And both 3 electrons are having what? They experience what? Different nucleus filling. Right. That is energy difference. Okay. I'm going to find out what the energy difference of each orbital. Okay. First important, I'm going to find out the radius of shells. Okay. And second, that is Rn. This is radius. Okay. Rn. I'm going to find out. Or use a small Rn. Okay. Radius of subshell. And second, I'm going for energy of orbital. Energy, very, very important. That is En. Okay. This very important, the two things I'm going to find out using what? Using the Bohr atomic model. Okay. I'm going to go the direct formula how to find out the radius of given atom. Now you have to understand very important. The Bohr atomic theory is only applicable for one electron system. For one electron system. Okay. Which is one electron system? Very important example. Hydrogen atom. Which atom? Hydrogen. Hydrogen-like species. What are hydrogen-like species? For example, hydrogen, 1 electron, right? Yes or no? Helium, how many electron? 2 electron. And helium plus is 1 electron. Lithium is 3 electron. And lithium 2 plus is 1 electron. Okay. Therefore, this 3 system is applicable for what? The Bohr atomic model. Simply we call what? We tell the one only applicable for what? The 1 electron system is applicable for what? The Bohr atomic model. Now, I'm going to give the energy formula in different unit. Okay. Please note. Say energy. First, radius. See the radius formula. Very, very, very important. Please note. The radius of N. Okay. N is what? Shells. Okay. Or N. The radius of N that equal to what? The 0.529 into N square by Z into Armstrong. What is the unit of radius? Armstrong. This is very, very important formula in our NEET exam point of view. Okay. Now, we're going to find out Bohr radius. What is Bohr radius? Please know. What is Bohr radius? Bohr's radius. Okay. Listen, the Bohr did the experiment based on hydrogen atom, right? So in case of hydrogen atom, what is number of electron is 1. Okay. Therefore, it's a nucleus. Only one subshell. Only 1 electron is possible, right? That is 1 electron which subshell is present. N value is 1, right? N value is 1. Now you know for hydrogen atom, N value is 1. What is that value? What is the number of electron? What is number of electron? 1. They're also 1. Okay, now apply the formula, that is radius of hydrogen that equal to what? 0.529 into the 1 square by and 1. Okay, 1 and Armstrong. Now what is the value? Is around the radius of hydrogen that equal to 0.529. That is what? The Bohr radius. Okay. What is the Bohr radius? 0.529 Armstrong. Okay. Using Bohr radius, they asking what? What is radius of lithium 3 plus? They will ask. Lithium 2 plus, sorry. They will ask. Okay. They will going to correlate with what? The lithium 2 plus versus hydrogen atom. Okay. They will ask how much difference between what? How much radius difference between the lithium 2 plus and the radius of hydrogen. They will ask an exam point of view. Okay. This is very, very, very important. Please note this is a very important formula in our exam point of view. Next one is also very important. That is energy formula. Please note. En, the energy of N shell. What is the formula? Please note. There are different formula based on different unit. Okay. The value should be minus 13.6 into Z square by N square. Z square by N square. This square N square. This is electron volt per atom. Listen, this is remaining same. This is not changed. This is remaining same. This only going to change. Okay, based on unit. In case of electron volt per atom on the minus 13.6. Okay, mostly we can use this formula only exam point of view. Put the star on this. Okay, and second formula, please note the energy of N shell. What is the value? Is around the 3.1 is very, very important. The minus the 1.3 and 1.2 Z square by and N square. Okay, what is the unit? The kilojoule per mole. Kilojoule per mole. Okay, one more formula also available. That is En. That equal to what? That equal to the minus the 313 the 0.6 into Z square by and N square. The value around what? The kilocalorie per mole. Okay. This is very important 3 formula, but in our exam point of view, we're mostly applicable on which formula only. The first formula is very, very important compared to other 2 formulas. Okay. Now, what is it we find out? We find out what? What is the energy of this subshell? Okay, this N value. Okay, this subshell, and similarly, we are going to find the energy of radius of the n orbital, right? Now next target, listen, it is nucleus, right? Now this is electron. Okay, now you know electron revolving the nucleus, right? Now what is the velocity of this electron? This electron what? Revolving around the nucleus, right? Now this, what is the velocity of this electron? I'm going to find out what? Apply the Bohr theory. Now please note that is the velocity of electron. Okay, the velocity, very important, that is Vn. Okay, the velocity of electron, this velocity, please note, this is velocity. Okay, and this is energy. This is energy, very important. Okay, so what is the formula? This Vn, that equal to, please note, very important, the velocity in n shell, that equal to what? Z by n. Okay, there is no square. Okay, Z by n into 2.185 in 10 power 8 the meter per second. Okay, centimeter per second. Okay, centimeter per second. This is a very important formula to find out what? The velocity of the given nth value. Okay, now next target, I'm going to discuss hydrogen spectra. This is very important. Please note, hydrogen spectra. This is very important. Okay, our example topic. Now see, please note, hydrogen spectra. Hydrogen spectra, very important. Hydrogen spectrum. Okay, listen, in hydrogen spectrum, there are the different spectral lines possible. The spectral lines are obtained. Okay, what is different spectrum line? Now note. Okay, now I'm going to the energy levels. This is energy level. Please note, this is energy levels. Okay, now see. Okay. Now first one, the series. Okay, this is n. This is n value is equal to 1. Okay, there is not 0. Okay, n value is 1 only. This is n value is equal to 2. Okay, now this is n value is equal to 3. Okay, n value is equal to 3. Sorry. Okay, this is n value equal to 3. Now n value is equal to 4, right? This is n value is equal to 4. This is n value is equal to 5. Now I'm going to give the name for the given shells, given n value. Okay, given n value. First one, please note, n value is equal to 1. That is a Lyman series. What is first series? This is Lyman series. Okay, Lyman series. And second one is Balmer series. Okay, Balmer series. And third one is Panchan series. P-A-S-C-H-E-N. Panchan. Okay. And fourth one is bracket. It's the name of series. Okay. Bracket. Actually, scientist name. Bracket. This P-Fund. P-Fund series. Hembry series. The scientist name. Okay. Hembry series. Hembry. Okay. Hembry series. Okay. This is a series. Now see. In this case, this is a hydrogen spectra, is a emission spectra. Okay. Emission spectra. Now see, now electron going to emit. Listen, this is a Lyman. What is Lyman series? Now, what is the possibility? Now listen, this electron going to N2 to N1 level, right? This also possible, and this also possible, and this also possible, right? For in case of Lyman series, please note, in case of Lyman series, what is N1 value is always 1. What is N2 value? N2 value what? N2 value can be 2, it can be 3, it can be 4, it can be 5, it can be 6, right, sir? No. In case of Balmer series, what is Balmer series? What is N1 value? It should be 2, right? This is a standard. Okay. What is N2? It can be electron what? Emitted from 3 subshell and 4th one and 5th one and etc. Right? This way you can find out what? Using this hydrogen spectra, I am going to find out what is the wavelength of this series as well as what is the wave number and lambda I'm going to find. Wavelength I'm going to find out. Okay. Now please note, I'm going to give you information. Please note, in Lyman series, okay, the Lyman series and Balmer series, and then is Panchan series, okay, and bracket series, okay, then P-Fund and Embry series, Hembry series, okay. Now what is the range of this series? Now please, very important, okay. The Lyman series is a UV range, okay, UV range, and Balmer series is visible range. Very important. Which is visible range? Only the Balmer series, please note. Okay, the Lyman is UV and Boltzmann is visible, and other force are what? IR, infrared series, infrared. Okay, this is very, very important. Now, in exam, they asking which is under the category of visible series. Na, what is answer? Answer is Boltzmann series. Okay, now I'm going to go with the direct formula to find out what? To find out the, okay, what is find out the wavelength. Before going to find out, I'm going to tell you, please note number of spectrum line, number of spectrum line. Okay, number of spectrum line. For example, okay, now this electron is for example. Okay, now see, okay, the electron present in fifth subshell. Okay, now this electron going to come to the Bormal series. Okay, now how many transition possible, right? This also one, yes or no, and this is 2 and this is 3. Okay, every time you can able to draw the structure line, draw the line, able to find out, right? Going to give the short notes, please note what is the short formula. Okay, number of spectrum line that equal to what? And n into and n minus 1 by 2. Okay, what is n value? N is higher, the higher value. Please note what is n? Higher energy level. What is I? N, higher energy level. Higher energy level. For example, okay, the electrons are emitted from, okay, n value 5 to, okay, the n value 2. Now, how many spectrum will possible? Okay, now how to find out, okay, which is higher energy? N5 is higher, right? This higher energy. Okay, this is lower energy. Now, how many spectrum line? The number of spectrum line, the number of the spectrum line. What is the formula I give? N5 and 5 minus, this is 5 minus 1 and by 2. Okay, and 5 into 4 and by 2. Answer is what? Answer is 2. Answer is 10. 10 spectrum line is possible. Okay, using this formula, I'm going to find out the number of spectrum line. This is very, very important formula. Now, this is very, very important. Going to tell is very, very important. Please note this is exam point of view. Okay, this is exam and point of view. This is very, very important. Okay, in our NEET exam. Based on this formula, they are asking many questions in our previous NEET exam. Please note. They are asking what? The wavelength of the line. Okay, this 1 by and RH. 1 by RH equal to what? N1 square and N2 square and divided by and N1 square and minus and N2 square. Okay, using this formula 1 by the square. Using this formula, we're going to find out what? The lambda wavelength. Next is wave number V. Okay, V bar or 1 by lambda. What is wave number, right? What is the formula? Please note this RH in RH equal to what? The 1 by N1 square and 1 by N1 square and minus and 1 by N2 square into Z square. Okay. Now, what is RH? Ribet constant, right? Please note what is RH value. What is RH? Ribet constant. Ribet, okay, REDBERGS, Ribet constant. Okay. Now, please note what is RH value. The RH value is around the 1.097 in 10 power and minus plus 7. Okay, plus 7 and meter inverse. Okay. Now, what is 1 by RH? I give you the ready value. Please note what is 1 by RH value around what? Over 9 point and 1 into and 10 power and minus 8 meters. Students understand in a NEET exam there is no calculator allowed, right? We have to make the ready vector. What is ready vector now? We have to make a values. We know RH. What is RH value? 1.097 in 10 power 7 meter inverse. What is 1 by RH? In the exam, you're going to do what? 1 by is very difficult, right? We have to make the ready vector. What is ready vector now? Already you know the value. What is 1 by RH? The 9.1 10 power minus 8 meter. Okay. Understand? Very, very, very important. Okay. Now see, this is very important. This is a Lyman series, right? It's a Lyman. This is the first N21, N2 to N1. This, okay, this is N2 to N1. Understand? Similarly, this is N3 to N1. Okay. Now this is higher energy. For example, N3 to and N1 is higher energy. Similarly, the N2 to N1 is lower energy. Okay. Now in this case, which higher energy? N3 to N1 is higher energy and N2 to lower energy. Higher energy means what? Lower wavelength, right? Because energy, okay, inversely proportional to what? Wavelength. Okay. In the exam, they are asking energy difference, wavelength difference. Using these two formula, we're going to find out what? The energy of that transition and the wavelength of that transition we're going to find out. Okay, this is very, very, very important in our exam point of view. Okay, energy you can find out what Bohr atomic theory. Okay, this apply this formula, you find out the energy. They asking the wavelength. Okay, they ask the wavelength or wave number. What is V bar? This is wave number. This is wave number. Okay, wave number. Using this formula, we can find out what wave number. Okay, very, very, very simple. Okay, now and third important concept is a de Broglie equation. Please note this is about hydrogen spectra. Okay, Now, please note the de Broglie equation. Very, very important. You have to use small letter. Okay, French scientist. De Broglie. Okay, de Broglie equation. De Broglie equation. Okay. Now, what is de Broglie equation? We know very well, right? What is de Broglie equation? That is two scientists, right? E is equal to an mc square. It's an Einstein formula. And E is equal to h nu is a Planck equation. Okay. Using this equation, I'm going to derive the formula. That is lambda is equal to and h by mv. Yes or no? H by mv. What is the mass into velocity? What is the mass momentum, right? Therefore, the mass into velocity that equal to p. This is momentum. What is the finalist formula? The lambda is equal to and h by mv. This is what? This is a formula for what? The de Broglie. What is h? It's a Planck. What is Planck constant value? The 6.626 into the 10 power the minus 30 and joule and per second. Okay. This is a value of what? Value of the Planck constant. Okay. This is very, very important. Okay. Listen, it's not basic, right? They will not ask an exam. Okay. Now, what is the important thing? Please note. Now, I'm going to derive this equation lambda. What is lambda? That is equal to what? And h by and square root of and 2me. Okay. What is E? Okay. Potentials. What is E? E nothing but what? Electron volt. Okay, electron into other volt difference. That is E. Okay. Now they ask you what? Thermal de Broglie wavelength. Please note. Very important formula. That is de Broglie wavelength. De Broglie wavelength. They will ask an exam. De Broglie wavelength. So what is de Broglie wavelength? Okay, for different species or different formula, right? For electrons, what is the formula? For electron, the thermal de Broglie wavelength, that is lambda is equal to, okay, lambda is equal to, that is value, the 12.27 by, okay, volt difference in Armstrong. And in case of proton, please note value of thermal de Broglie equation, okay, for the P plus proton, right? What is the value? Please note. The lambda is value is around, the lambda is equal to, the value around what? 0.286 and square root of velocity, okay, into Armstrong. This is not velocity is volt, okay, very, very important. Okay, using this two formula, we are going to find out what? The thermal de Broglie wavelength of electron and the proton. Okay, now next very important basic information, that is called what? Heisenberg uncentered principle. Please note. Next important, Heisenberg's uncertainty, SCR, uncertainty principle. Okay, what is this principle? It is impossible to measure simultaneously the position of particle and momentum of particle and simultaneously, right? Now, what is the formula? Please note. I give and delta x position of uncertainty of position and delta p, okay, uncertainty of momentum are not are equal to or greater than or equal to and h by and 4 pi. Okay, we also call what? The delta s and delta p that are equal to and h cap by and 2 pi. Yes or no? What is h cap? The h cap is equal to what? That is h by 2 pi. It is very important. You know the formula, right? Yes or no? Now, what is delta p? We know what is delta p. That is mass into velocity, right? Yes or no? Now, we can replace this formula and delta x, okay, and delta v into m, okay, and equal to and h by 4 pi. In the exam, they asking what? The velocity or momentum, velocity or position, right? I will take the velocity and delta v that equal to and h by and 4 pi into and delta x into mass. Okay. Or they will ask what? They will ask also position. Therefore, the delta x that equal to and h by and 4 pi and the delta v into m. Okay. This is two important formula. They find out what? Uncertainty of position and as well as uncertainty of velocity. Okay. Now this is not okay. This only is not Heisenberg. Okay. There are different two formula for Heisenberg. Please note. Very important. Okay. This is very, very important. See, so in this case, what? Listen, position momentum also uncertainty, right? Similarly, please note, an energy and time. We cannot find out simultaneously. The energy and time. Okay. Are also what? Greater than or equal to h by 4 pi. Similarly, the angle theta and angular momentum pi, both are also uncertainty and h by and 4 pi. Okay. This two formula also what? The Heisenberg uncentered principle only. Okay. Listen, in the exam, they will ask what? They will ask either velocity or either quotient they will ask. Okay. In our exam point of view. Okay. This is Heisenberg uncentered principle. Now I'm going to enter the next very most important topic, that is a quantum number. Please note. Quantum number. Very, very important. Okay. Quantum number. Please note. Quantum number. This is a very, very important topic. Okay. Now what are four quantum number? Right? First one, please note. Principal quantum number. Okay. Principal quantum number. Principal quantum number. What is representation? That is n, right? Small n. Quantum number. That is small n. Okay. Listen. The principal quantum number tell about what? Tell about the first point, energy level. Very, very important. Okay. They tell about idea about what? The energy levels. Energy level is a very, very important formula. Important, okay, things involved. The principal quantum. Okay. I give you the I'm going to give the important formula. Please note. Okay, the maximum number of orbitals. The maximum, the number of orbital that equal to what is the formula? N square. Okay. And maximum number of electron in orbital, the maximum, the number of electron, okay, in orbital, what is the formula? That is 2n square. Understand? Now, okay. The orbital angular momentum, very important. Orbital angular momentum. Orbital angular momentum. What is the form? That is nh by 2 pi. nh by 2 pi. Now see, I'm going to give the example, now only understand. Okay. Now I take this one. See, this is a nucleus, right? This is nucleus. This is 1, this is 2, this is 3. Now this n value is 1, this n value is 2, and n value is 3. Okay. Now how many electrons per? What is the formula? Number of electrons? The number of electron given subshell. That was the formula 2n square, right? Now put your n value is equal to 1. Okay. What is the value? That's 2 into 1 square. Around what is value 2? It's a 2 electron. Here 2 electron, right? N value 2 pota 2 square into 4 into 8 electron. 1, 2, and 3, and 4, and 5, and 6, and 8. Okay. Now in n value 2, how many orbitals present are? How many orbitals? What is the formula for orbitals? That is n square, right? So what is 1 square? Is only 1. Therefore, this is only 1 orbital. S orbital. Okay. Now n value 1. Okay. N value is equal to 1. See, n value is equal to 1. How many orbital? Only 1 orbital is s orbital. This is s orbital, right? S or no? S orbital. Now what is n value is 2? How many orbital formula? This is 2 square, right? The number of orbitals, what is the formula? That is n square, right? Therefore, what is 2 square? This is a 4. Okay. Now listen, we know very well each orbital, how many 2 electron, how many electron maximum? One is clockwise, one anti-clockwise. Okay. How many electron? Is only 2 electron occupied. Okay. Therefore, how many are 4 orbital? One is s orbital, then 3 p orbitals. Yes or no? 3 p orbital. This is s orbital and this p orbital. This one s orbital occupies 2 electron. Okay, 2 electron, and this p orbital occupies 6 electron. Therefore, how many electrons come? What is formula? 2n square, right? Therefore, how many? 1, 2, 3, 4, 5, 6, 7, 8 electrons per. Now understand? Okay, this 8 electron, how is it distributed now? The 2 electron s orbital, the remaining 6 electron p orbital. Okay. Now, what using the principal quantum, I will find out what? We will find out the number of orbital and number of orbital in the given shells. Okay. Now, second one is very important. Azimuthal quantum number. Please note. And second quantum number, that is azimuthal quantum. This is Z value. Azimuthal quantum number. Azimuthal quantum number. Okay. They represent Z. L. Sorry, is represent L. Okay. Now what is L? L value is equal to, L value is equal to 0 to n minus 1 value. N minus 1 value. Okay. What is L value tell about? What is azimuthal quantum tell about? The shape of orbital. Very, very important. The shape of orbital. Shape of orbital. What is shape of s orbital? S orbital shape is spherical. S orbital, what is shape? It's a spherical. Okay. And p orbital double shape. P orbital. What is shape of p orbital? It's a dumbbell, right? It's a dumbbell shape. Yes, I will write properly. Okay. It's a dumbbell shape. For d orbital, double shape or flower shape. It's a double shape. For f orbital, complicated. Okay. This is a plus sign. This is a plus and minus and plus and plus and minus. Anyone tell me what is plus minus? Okay. Tell me in comments. What is a plus minus represent what? Okay. Tell me in comment section. Okay. Understand? Okay, what is azimuthal quantum number? I tell about what? The shape of orbital. Okay, now I'm going to give you the important data about the L value. Please note, very, very important. Okay, now L value, okay, it can be 0, it can be 1, it can be 2, it can be 3, and it can be 4, or it can be 5. Okay, for N value is equal, L value is equal to 0, belong to S orbital, and N value is 1 belong to P orbital, and L1 into is a D orbital. Okay, N value is 3 is a F orbital, and N value 4 is G orbital, and N value is 5 is H orbital. Okay, this is the very, very important in our exam point of view. Please note. Okay, very, very important. Now, okay, now very next formula. Please note what is orbital angular momentum. Please note the formula is orbital angular momentum. What is the formula? Orbital angular momentum. What is the formula? Please know that is h by 2 pi and square root of and L into and L plus 1. Okay, I do one problem, you will understand. Okay, for exam they asking, okay, they asking the orbital angular momentum for the orbital, the angular, the momentum of angular, the momentum of, okay, the 2p orbital. They are asking 2p orbital. Now you know very well what is the formula. That is theta is equal to what? Theta is equal to and h by and 2 pi. Okay, you take pi is equal to what? Square root of and L into and L plus you reference L also. Okay, what is the formula? What is 2p or 2p subshell, right? What is 2p? Okay, in case of 2p, so what is what is L value? Belong to p orbital. What is L value now? For P, what is L value? 1, right? There I put 1. Now apply the formula. What is the answer now? And theta pi L is equal to and h by and 2 pi square root of and 1 into and 1 plus 1 value are around the h by and 2 pi into root 2 is a value. Okay. Similarly, you can find out the value of what is 3D and 5F. Okay. Tell me in comment section. Okay. What is angular momentum? What 3D orbital and 5F orbital. Okay. This type of question asked in exam very, very, the previous question is very, very important in our exam point of view. Okay. And next third quantum number is very important. The magnetic quantum number. Please note. So magnetic quantum number. Third one that is very important. The magnetic quantum number. That is magnetic quantum number. Okay, what is magnetic? What is represented as ML? ML. Okay, please note this. Represent the orientation of orbital. Represent the orientation of orbital. Very important. Orientation of. Okay, orientation of orbital. What is the formula? Please note the orientation equal to what? The formula is equal to the 2L plus 1 is a formula. Okay. For S orbital, what is L value? 0. What is orientation? The 2 into 0 and plus 1. Therefore, what is answer is 1. Therefore, only one orientation. What is the ML value? That equal to 0. There is no possibility, right? Okay. Now, P orbital. What is L value is 1. What is orientation formula? And 2 into 1 and plus 1 value is 3. Therefore, the 3 orientation, right? I put 3 box. Okay. Now you know very well this is Px. Okay. This is Py and this is Pz. What is orientation? The ML value is very important. The ML value is Z. Okay. And ML value, this is plus 1 and 0 and minus 1. Yes or no? For D orbital, what is L value? Is 2. What is orientation? The 2 into 2 and plus 1, the value is 5. 5 orientation, right? Put 5 box. What is a 5 orientation? Now 1, 2, 3 and 5. This is minus 2 and minus 1 or plus 2 and plus 1 and 0 and minus 1 and minus 2. 5. What is 5? What are the 5 D orbitals? Please know we know very well. What are 5 D orbitals? Okay. See, one is dxy. Okay. One is dxz and dyz and dx square hyphen y square. Okay. And d is a square. Okay. D is very, very important. This is 5 D orbital. Okay. In P orbital, Px and Py and Pz. S orbital, only one S orbital. Okay. S orbital. You understand? Okay. The magnetic number tell about what? The orientation orbital. Okay. For D orbital, there are 5 orientation. That is dxy and dxz and dyz and dx square minus y square and dz square. For p orbital, there are three orientation, that is px and py and pz. Okay. Now the fourth one is very, very important, the principal spin quantum number. Okay. What is fourth one? Please note. Spin quantum number. Simple, right? Spin quantum number. Spin the quantum number. Now, note. What is the formula? See. Listen. And one orbital, how many electron? 2 electron, right? Is this 2 electron, one is clockwise, other is anti-clockwise. Okay. This is clockwise electron. This is clockwise. Okay. This is what? This is anti-clockwise. Anti-clockwise. Listen. This also what? Okay. This is anti-clockwise. Right. Now see, understand. Okay. What is clockwise spin? This spin value is around what? The S value is around the plus of. And this value is around what? Minus of. Okay. This is spin quantum numbers. Understand? Very simple. You know, it's basic thing, right? Okay. Now I go. What is one? Please, this is also very important. The spin angular momentum. The spin angular momentum. What is the formula? Angular momentum. Same, right? What is the formula? That is h by and 2 pi and square root of and s into s plus 1. Okay. It's very, very simple one. Okay. Using this formula, I'm going to find out what? The spin angular momentum of the given electronic configuration. Now I'm going to tell about the very important three rules. One is half-half principle and Pauli exclusive principle and the Un's rule. Okay. This is a very, very important rule in our exam point of view. Okay. Before enter to this rule, I'm going to tell about some important terms called nodes. Please note. What is node? It's very important thing. Node. Okay. It's orbital. Okay. Node. It's only for orbitals. Node. Nodes. For orbital. Okay. Now see, this is p orbital, right? This is p orbital. Actually, what is a p? This is a p orbital. This is a given book. This is a wrong one. What is actual p orbital shape? This is p orbital shape. This is actual p orbital shape. Okay. Now see, what is orbital? Please first you have to understand. What is orbital? Nothing but what? Electron density. What is orbital? Electron density is orbital. Now this full electron density. Electron density. Okay. This is electron density. So see. Now in this point, see this point, this point. Okay. There is this point, no density, no electron density, right? Yes or no? No electron density. Now what is node mean? Please note. Okay. What is node? Okay. What is nodes? The electron density is near not zero. Okay. Density. The electron density is near to zero. Is near to zero or called node. Okay. Now nodes are classified two types. One is a radial node. One is a radial node. Okay. Radial node. And second is angular node. Second one is angular node. Okay. I give you the formula in this slide. Please know, very, very important formula. Okay. First node, total node. What is the formula? The total, the node that equal to n minus 1. Okay. Now, what is radial node? Please note. The radial node, what is the formula? That is n minus L minus. Now you know what is n? Principal quantum. What is L? Azimuthal quantum. You know how to find n and L value, right? Now what is angular node? Angular node. What is the formula? That is L. Okay. This is L value. This is very, very important. See, I do one problem. See, please note for s orbital. Please note for s orbital. If I take s orbital, okay, listen. I take any s. Okay, I take 2s. I take 5s. I take 10s also. It's possible. Okay, 10s also. What is L value for all the s orbital? 0. Therefore, the s orbital, okay, do not have angular node. S or do not have angular node. It's only have radial node, angular node. See, this is a representation. N, L, S. Okay. What is N? Principal quantum number. Energy level. This is energy level. Okay, energy level. What is L? Azimuthal quantum number. It's orbitals. Orbitals. Okay. What is SA? Electron. For example, I take 2s2. Okay, this belongs to second energy level. Okay, and s orbital. This is s orbital. S or no? This belong to what is energy level? N value is equal to second energy level. Okay. How many? 2. This is a representation. Therefore, whenever this front is to front end value, they represent N value. Okay. This S belong to what? L value. This 2 represent the electron count. Okay. Using this 3 formula, I am going to find out what? The radial node and angular node of the given orbitals. Okay. See. I give one problem again. Okay. I take 4D orbital to find out the radial node as well as angular node. Okay, now we do very simple, right? Angular node. What is radial node formula? The radial node, what is the formula? That is n minus and l minus 1. What is n value? So it belongs to 4. Which are where d orbital? What is l value? 2 and 1. What is answer? Is 1. Okay. What about the angular node? Angular node. What is the formula angular node I given? Is equal to n, right? Is equal to L. What is L value? D have 2. Therefore, how many node? The 1 radial node and 2 angular. What is 3, right? What is total node? N minus 1. What is n value? The 4 and 4 minus 1 is a 3. In 3 node, okay, the 2 nodes are angular and 1 nodes are what? Radials. Okay, this way they will ask in exam. Okay, how many radial node? How many angular node? Okay, now I'm going to start. Okay, going to start the electronic configuration. Okay, we're going to apply the 3 rules to write the electronic configuration. Please note. Very last topic. Okay, electronic configuration. Very important. Please note. Electronic configuration. Electronic configuration. Okay, this concept I will teach again the periodic classification. Already I upload the one-shot video of periodic classification. I will give the link in description. You can watch. Okay, that video I will tell how to write the electronic configuration. Okay, please note. Now, first rule is alpha principle. So what is alpha? First rule, that is alpha principle. That is alpha principle. So what is alpha? Scientist name? No, it's a Greek letter. It's a Greek letter. What is alpha mean? It's a building block. It's a building block. It's alpha. Alpha, right? Alpha, not is alpha, alpha. So what is a representation? This oneness we know. Here 2s and 2p. Here 3s and 3p and 3d, right? This is 4s and 4p and 4d and 4f, right? In this case, this is 5s and 5p and 5d and 5f. Okay. Now, how to represent? Listen. What is alpha principle? The electrons. Please note. The electrons are filled in increasing energy levels. Yes or no? Now see, 1s and 2s and 2p and 3s and 3p and 4s and 3d and 4p and 5s and 4d and 5p, etc. Okay, this is a person. Okay, see, first 1s low energy, then 2s, then 2p, okay, then 3s, then 3p, then go for 4s, then 3d. Very important. Okay, this is very important. D block element 3d, then 3d 4p, okay, and next and 5s, okay, 5s, then 4d and etc. Okay, this way you can write what? The using this alpha principle, we can write what? Electronic configuration. Okay. In this exam, they will ask a 4 energy level. For example, they give the 4 energy. For example, okay, they give 5s, okay, and 4f and 3d and 4f, okay, 4d. They give the 4 orbital. They write, but they will ask what? Arrange the increasing level. Okay. Every time you will not write this way, right? I'm going to teach the another way of the electronic configuration, filling the electron configuration to find out the energy level. That is called what? The Bohr-Bury rule. Please know. What is second rule? That is very important. The Bohr-Bury rule. Very important. This is Bohr. Again, I'm scientist. Bohr-Bury, 2 scientists. Okay. Bohr and Bury. Bohr-Bury rule. What is Bohr-Bury rule? Also called N plus L rule. Please know. That is, what is other rule? That is called N plus L rule. That is N plus L rule. Okay. Now see, first point, very important. Higher the N plus L value, higher the N plus L value, higher the energy. Okay. High energy. Understand? And second, please note, lower the N plus value, lower the N plus L value, lower the energy, low energy. Okay, low energy. If the n plus L value, if n plus L value is same, and look n value, higher the n value, higher energy, high energy, and lower n value, low energy. Okay, this is very important formula. Now see, in case of 5s, okay, what is n value? 5. What is L value? SR will belong to 0. So what is n plus L value? Is n plus L. Okay, is equal to 5. Understand? In case of 4f, what is n value? That is 4. What is L value? That is F orbital 3. What is n plus L? 7. Understand? Now 3D, what is n value? That is 3. What is L value? D belong to 2, right? Therefore, 3 plus 2, 5. Okay. Now 4D orbital, what is n value? That is 4. What is L value? Is 2. 4 plus 2, 6. Okay. Now what is high energy level? 4F, right? The 4F is higher energy level. This energy, okay, energy level. The 4F is higher. Then go forward. This is 7, right? Now again 6, 4D is higher energy. Then this one, this also 5, this also 5. Same n plus value. Look the n value is 5, n value is 4. Which higher the value? 5. Therefore, here 5s and then and 4D. Sorry, 3D. Okay, 3D. This way, I am going to find out what? The energy of the given orbital using what? Using the Bohr-Bury rule. It's very, very important in our exam point of view. Okay, I am going to enter the third rule. That is what? The Pauli exclusion principle. Please note, very important. That is Pauling's exclusive. Okay, Pauling's exclusive. This scientist got 2 Nobel Prize in chemistry. Pauli exclusion principle. It's very simple, right? Principle. Okay. What is principle said? Please, what is principle tell? Now, please note. No 2 electron. Very, very important formula. Okay. Very, very important statement. Please note. The 2 electrons, electrons in an atom, okay, can have all 4 quantum numbers same. All 4 quantum number is same. Quantum number is same. என்ன சொல்றாங்கன்னா ஒரு 4 quantum number இருக்குல்ல அது எந்த ட்ரெண்டோட சேமா இருக்கு. For example, I take this p orbital. This is a p orbital. C is a p orbital. This is ml value. Okay, this ml value is a +1 and 0 and minus. Okay, now I'm going to fill this one 2p2. I write this like, okay, I write this like. Now see, for this electron, okay, this is belong to 3p subshell, for example. Okay, 3p. Now I take this one. For this orbital, what is n value? This electron, okay, this electron. What is n value? 3. This electron also belong to which subshell? And this also n value 3. Okay, what is L value? That is p orbital, right? This is also p orbital. Therefore, n value is 1. This also which orbital? The p orbital. N value is L value is equal to 1. Now, what is the ml value? These 2 electrons present, ml value +1, right? This ml value is +1. This also, the ml value is equal to +1. But what is S value? This is clockwise. This is plus of, very, very important, plus of, and this is plus of. Okay, right. This value is plus of, right? This is S value. Please note. The S value, this is clockwise, right? Clockwise. S value, that is plus of, and this S value is minus of. Okay. This is a Pauling same. Okay. This n value is same, and L value is same, and ml also same, but S value is not same. Okay. For any 2 electron, okay, they do not have what? At least 1 quantum number, it can be different. Okay. It's a Pauli exclusive principle. Very, very, very important. Okay. And last final one, Un's rule. What is Un's rule? You know very well basic things, right? What is Un's rule? Please note. Fourth one. That is Un's rule. Un's rule. Okay. Okay. The electron pairing in PDF orbital. Please note the statement. Please note the electrons pairing. Okay. P and D and F orbitals very important. Orbitals. The first the take of field. The first take of field. Sorry. The first field. Okay. First field of field. Of field of field, okay, and of field, of field, and followed by, and followed by fulfilled, followed by fulfilled, okay, fulfilled. See, simple. In case of P4 configuration, in case of P4 configuration, I'm going to fill the electron, right? This is a p orbital. First, I do off fill, right? How can I fill the electron? See, how can I fill the electron? Simple, right? See, this is a P3, right? P4. How can I fill the electron? Simple. First, I going to fill off fill, right? 1 and 2 and 3 and 4. This is correct represented. If I do this like, in case of 4p, I write this like, okay? This is completely wrong because, okay, first you have to do off fill, then go forward, further field, okay? In case of D7, what is representation, okay? How many 5d orbital? 5d orbital, right? 5d orbital, this 1 and 2 and 3 and 5d orbital, okay? How can fill it? First 1 and 2 and 3 and 4 and 5 and 6 and 7. This is correct. Okay. In case of P3, okay, what is the different way I going to arrange? See, first off field, right? This 1 and 2, 3. This is correct one. See, this is correct or wrong? Tell me this one correct or wrong. I will write. Tell me correct or wrong. This correct or wrong? This is wrong. Yes or no? This is correct or wrong? This is correct or wrong? See, this correct or wrong? This also correct, okay? Either 3 electron in off spin or either 3 electron down spin is allowed, okay? This is not allowed. For example, I put 1 electron is off spin, okay? Remain 2 electron down spin. This is not allowed, okay? This is unstood, okay? First, you have to pair the electron off field, then go for what? The full field, okay? This is a single shot of a one shot video of a atomic structure. These are very, very important topic in our NEET exam point of view. Okay, and any doubt you can ask in comment section. And tata, bye bye, and see you next lesson and as soon as possible, and take care. Tata.